Yeah.
Hey there.
Howdy.
Mic check.
Hey,
Think we
everyone.
got. Hey, what's going on? Think we have everyone here. Daniel, Justin. By the way, is it Nikhil? I want to pronounce your name correctly. I'm sorry if I got that wrong.
No, that was perfect. You nailed it.
Nikhil. Okay, so we got Daniel, Justin, Nikhil, Eric, and Matt. And it sounds like everyone's here, so we can get started.
I think Matt's a listener.
Yeah, he's connect. I
and
see the connecting, buffering thing happening with him.
got it.
So,
And then
Aaron
Eric.
as well. Ooh, sorry, Aaron, I
Yeah.
forgot about you. Yeah, we got the whole
Yeah.
squad in here. All right, let's let Aaron buffer as well, and then once he's up here, we can get the show on the road. Daniel, thank you so much for putting this together, and looking forward to the show. Aaron is still
Appreciate
buffering.
y'all being patient.
What's that?
Hey, guys, can you hear me?
Appreciate y'all being patient.
Yeah, of course, man. Good afternoon, Whalecoin Talk community. My name is Noah. I'm here today with the Avalanche team, and guys, Avalanche is one of my favorite alt layer ones out there. Apart from your awesome branding and robust ecosystem, one of the aspects that really lured me in, and a lot of my friends who had never really played around with crypto but got into it during the bull market of 2021, was just how seamless the experience was, not just from bridging funds over, but just using the ecosystem, interfacing with DeFi, and all the great things that you guys have to offer in this, on chain. I want to just first go into a bit more detail as to why you believe, as folks that are helping build the ecosystem, AVAX stands out from other layer ones. What makes it so special?
Yeah, do you want me? I guess I can kick off, or
Yeah,
you
you guys can tag team this. No worries at all.
Yeah. Two things. One, the consensus layer, which we can go more in depth on. Novel consensus layer. There being only 3 in history, us being the third, is a huge why for me, and what got me so interested about 2 years ago. And then 2, you kind of touched on it, the team as a whole. So the best backgrounds in this space, designing the project from a bottom up perspective, coming out of Cornell University, really just bringing academia to the public forum was really exciting. That's and then since then, everything's been kind of just blossoming from there. So it's been a really fun ride. Nikhil, you want to go?
Sure. So, what Dan mentioned, I think there's a few interesting things that really, set Avalanche apart. Is like something that we like to say. So, as Dan had mentioned, one is consensus. That really means to everybody is transaction finality and decentralization. So Avalanche is the only network that can achieve transaction finality in under a second. I think there are blockchains that try to get come close, and I think the one that can come the closest without naming any names comes at around somewhere between 7 seconds and 13 seconds as a transaction. So by and large, Avalanche is the only network can do sub-second transaction finality, which means if you're a financial company, an investment bank, a high-frequency trader, frankly speaking, long term, there's only really one network that you can build on and you can leverage. Second thing is that decentralization. There are some blockchains that can achieve high speeds, but they have to sacrifice decentralization. That this just simply and in order to have high speeds, you need to basically cap the number they have at like 100 or 150, which we've seen, or they might have to have sort of.
Hey, Nikhil, I don't know if you're cutting in and out from me, but you're saying some awesome stuff here, and I want people to be able to hear it. I'm not sure if I'm just having the issue or if it's anyone else.
That my audio might be cutting out. Here, let me fix it real quick because he might have some interesting things. Aaron and Matt, I think, might have some things, and let me sort out my audio.
Yeah, his audio was rugging for me as well. Aaron, you want to take this, or you want me to take it?
Yeah, I can jump in. Yeah, it was rugging for me a little as well. Yeah, so I think one of the things that really separates out Avalanche from a lot of the other L1s that are out there is just what the user experience is when you get there. And that goes 100% towards Dan's point of that really comes from the consensus protocol. Prior to Avalanche and a lot of other L1s that exist now, the problem is just transaction latency. So a lot of people talk about throughput numbers, but the real problem that you're facing in terms of making the user experience as good as possible is transaction latency. So when you issue a transaction to the network, you try and do something, how long does it actually take before that thing is finalized, before you can move forward and say, okay, this action completed? And users are really used to doing this one action and then being able to say, okay, if I'm interacting in Web 2, I send this thing to the server and then it's done. Okay, I know that it happened. I don't have to worry about it. But in Web 3, we have these blockchains that you have to actually interact in this potentially Byzantine environment, and you really care about when something is fully finalized, because you're not only interacting with some Web 2 server like Facebook, where if you don't do it now, okay, you can just retry it again later. It can actually have a huge impact whether your transaction happens now or sometime in the future. And the same is true in trading as well, but for blockchains in particular, this is really, really important. And so for a large number of DeFi applications prior to L1s that have become a little bit faster, you were subject to trying to put in an order and then waiting and waiting and waiting for it to actually finally go through. And even more so for different bridges that would basically move funds from one blockchain to the other, and you might have to wait for the finalization time on both before you could even custody the funds. And Avalanche, by bringing that confirmation time down to around 1 to 2 seconds, really just improves that user experience a ton. And I think that's why we're hearing from you guys and from a lot of other people as well, that they really like interacting with Avalanche. It's just that it enables those seamless user experiences where we're really starting to at least try and get to that point where you can interact with the blockchain and not actually know that you're interacting with the blockchain. I think that's really sort of like a holy grail in where we're going in this space is, can blockchain actually be something that is a better thing to build on top of, a better system to build on top of in order to build secure, distributed, reliable systems? And if the answer is yes, then okay, that's great. I don't want to know if I'm interacting with Facebook. I don't want to know if they're using SQL, NoSQL, anything like that. And in the same way, I don't want to know if I'm interacting in Web3, if I'm interacting with Avalanche, Ethereum, Polygon, anything else. I just want it to work. I want it to work quickly, and I want it to work well. And getting that transaction latency down to 1 to 2 seconds is really one of the first and most important steps in that.
Yeah, certainly on point. And I've made this argument several times that the future of mass adoption is when everyday folks are interfacing with Web3 without recognizing it, whether that's staking LP tokens, whether it's playing a Web3 game or playing around with NFTs. Things need to happen in a single click, and people don't need to see what's going on in the back end. So spot on, and I do see you guys doing that and making innovations on that end. I wanted to talk about the sub-second TX finality, but before we go into subnets and kind of how you guys how subnets kind of help achieve that, I want to take a step back and talk about the 3 blockchains supported by the same set of validators in the Avalanche ecosystem. So you have the exchange chain, the X chain, the platform chain, the P chain, and the contract chain, the C chain, which most of us are familiar with, the EVM compatible chain. But let's going first with the X chain. You mentioned, I think who it was mentioned, the Avalanche Consensus Protocol. How does the X chain exactly work? How does the Avalanche Consensus Protocol exactly work? And give us some more insight into that, please.
Yeah, I can answer that. So the X chain and so the X chain runs on Avalanche consensus, and the P chain and C chain both run on Snowman consensus, which is actually just a simplification of Avalanche, where Avalanche is a consensus protocol that's performed on top of some DAG, or directed acyclic graph, which basically just means instead of a linear chain, you can actually have one parent that has multiple children, and each of those can have multiple different parents. So it's a little bit more complicated, but the primary thing that both of these protocols rely on is the Snow family of consensus protocols. And this was the original research that was done at Cornell University with the co-founders of Avalanche, and has been iterated on for some amount of time now as well. And the idea of this protocol is just that we want to reduce the need to interact with every single validator in the network. And this is really inspired by gossip protocols, which have been used since, I believe, the 80s. There's a famous paper, Demers et al., I forget, something about eventual consistency. And it was inspired by the same thing, where instead of needing to interact with every single other validator in the network, where if you have 100 validators in the network, you have to ask all 100 of them, they have to ask everybody else in the network. And so as you start to scale that number of validators from 100 to 200 to 1,000, you start to see increasing latency, and you start to see more and more problems. The idea of Avalanche was that we relied on a gossip protocol in order to make that significantly more efficient. And the way that this works is, instead of asking every single other validator, which I'll just call like invalidators, you instead ask some subsample of the network. So for example, if there are about 1,400 validators in the Avalanche network today, But when you're running consensus on the Avalanche network, you don't actually ask every single validator in the network their opinion every time. Instead, what you do is you take some subsample of about 20 validators, and then you ask them, hey, what is your opinion on this thing? Let's say red or blue is the example that we typically give. And so if you see that 50% are red and 50% are blue, you say, okay, that doesn't give me enough confidence to move forward. So then you submit another sample, and probabilistically, if the network is completely split 50-50 between red and blue, even then, it's probably going to start to collapse towards one or the other, just because there's some probability that you'll end up a little bit more red or a little bit more blue in any given sample. And this is actually sort of an anti-stable property of the protocol, which causes the network, and everyone is doing this at the same time, so it happens even faster, but it causes, even if the network is at a 50-50 split, to start to collapse towards one direction. And what you do in that scenario is you start to repeat this subsample over and over again. And it's sort of like, if you flip a coin and you get a heads, how many times do you have to flip a coin in a row before you realize, okay, this is a fully weighted coin and it's going to land heads every time if you are observing that result? And the idea basically is, if you're repeating this subsample process, how many times in a row do you have to get a certain result to determine, okay, it is probabilistically definitely we've pretty much just how likely is it going to finalize after we've incremented our confidence to a certain point of probabilistically irreversible. So once you get to that point, you can mark something as decided, and you can actually achieve a similar safety parameterization, as it's so unlikely that it's the same as some very large number of reorgs in Bitcoin, which we don't really see. And so you can actually do this extremely quickly by relying on that gossip protocol and the fact that you don't have to interact with every single other validating node. And so that's how we get to two things: both the ability to see extremely low transaction latency and very high throughput, as well as the ability to scale to a very large number of validators. Because instead of interacting with all 1,000 validators in any given network query that we have to do, we're actually interacting with a much smaller number, which allows us to streamline it much more efficiently.
So say in this example, you have 100 validators, you take some subsample pool of about, you said 20 validators, and you say, let's decide whether it's red or blue. You'll keep asking, let's say 20 validators and then 25 and then 30, and eventually until you get the consensus to collapse to one side or the other. And eventually that's how finality is achieved, rather than asking all 100 at the same time, and this ultimately causes latency. I'm kind of just repeating back just to make sure I understood.
Yeah, so not quite actually. So I think I misexplained that slightly. So what you'll actually do is you'll repeat with the same sample size. So you'll ask 20 validators, and there are three important parameters here. There's K, which is the size of the sample, and it'll be the same size of the sample every time. And there's alpha, which is what portion of that sample does that have to respond positively for me to increase my confidence of that thing. So that has to be at least 50%. It has to get at least a majority. On the network, it's 15 out of 20. So if you get 15 out of 20 saying, yeah, I think it's blue, then you're going to say, okay, I think probably more likely than not, the network is leaning towards blue. So I'm going to increase my confidence. And the other parameter is beta, which is the number of polls in a row that I have to get in order to say, okay, this can actually be finalized now, because I know that I wouldn't get so many polls in a row unless the network had reached that point of irreversibility. So what's actually going to happen is you're going to send out a poll, ask 20 validators, you're going to get back, okay, all of them said blue, and then you're going to poll again, and after 20 consecutive polls with a different random sample of validators each time, you're going to be able to say, okay, I know that the network has reached this point of irreversibility, and I can finalize this transaction, this block, or this vertex.
Okay, got it. And I want to now tie this back to the exchange chain and the P chain, because I think a lot of people don't conceptually understand how these work. Can you do that for us? Because I would love to move on to the C chain, but first understanding how 2 out of 3 work.
Yeah, 100%. I think the idea for the primary network was that we wanted to decouple consensus from what state machine was in use, right? And so the way that Avalanche Go is architected, there is some consensus engine that just needs to be able to talk to some what we call a virtual machine that defines the state transition logic, the parsing of blocks, building of new blocks, etc. And so we wanted to separate that out so each one can be specialized to a specific use case. So I'll actually start with the C chain. The C chain is the EVM, right? And so you can run the EVM on Avalanche. It runs on the primary network, and that's what everyone knows and loves about Avalanche. A number of other networks have collapse all of the logic that's necessary in order to run a network into a single blockchain, but we took a slightly different approach of specializing out different pieces of functionality that we wanted into these 3 different blockchains so that they could be specialized and optimized for those use cases. So the C chain runs the EVM, as everyone knows and loves, and then the platform chain is the chain that actually orchestrates the validator set, staking, and delegations of the network. So the platform chain is its own state machine. It doesn't run on the EVM. It's not Turing complete. And all that it does is handle adding validators to the primary network, adding delegators to the primary network, as well as adding the creation of subnets, which I'm sure we'll get into more later, and orchestrating the validator sets of those subnets too. So this basically is orchestrating who is validating what is the portion of stake that corresponds to each validator in the network. And we separated this out from the EVM because there's no real reason to put it inside of the EVM. It's logic that's completely foreign to it. Other protocols have done things where they've had a need to handle staking in some way as well. And so some other protocols have actually baked that staking in as some smart contract. And as with many smart contracts, it's many smart contracts, there are bugs all the time, and so staking contracts have been no exception. It's not a problem with the projects or the protocols or anything. It's just that contracts end up having bugs and they can be hard to upgrade. And when you have a staking contract, it's incredibly important. It's incredibly fundamental to the protocol itself. So if that ends up being slightly harder to fix, it can be more difficult. And so I think it has actually been a really good decision to separate out the P chain into its own separate blockchain. So that is the only concern that we have there, all that it has to do, as well as the ability to optimize that for the P chain and have fault isolation between each of the 3 of them, which is really, really nice too. Does that answer your guys' question about the P chain? Happy to go into
Yeah, absolutely. No, I think that was perfect.
Cool, awesome. I'm sure we'll get more into the subnets later down the line too.
Yeah.
The X chain runs on a DAG, and it was intended to be optimized for simple transfers of some form of assets. So the fact that it runs on a DAG is intended to make it so that you can parallelize consensus more effectively. In a linear chain, there can only be one block at any given height. So each block has to have a single parent. Any 2 blocks that have the same parent obviously conflict with each other. A DAG doesn't have the same restriction. So the idea is that by loosening that restriction and still being able to perform consensus over it, you can actually parallelize consensus and improve the overall throughput of the system.
Got it. Okay. And so bringing these 3 together, they're all supported by the same set of validators. And before we get into subnets, I did want to talk a bit about the validators. At a high level, how many validators are currently supporting the 3 blockchains, and what are the minimum requirements with respect to tokens, software, and hardware to run a validator?
Yeah, that's a really good point to bring up, is just going back to who is actually validating this primary network. So yeah, to zero in on that point, yeah, 100%. The primary network consists of these 3 blockchains, and so anybody that is validating the primary network is validating all 3 of these blockchains as independent instances of consensus and independent state machines. But they are validated, as you said, by the exact same validator set, which is very important, because that means that all 3 of these blockchains are operating under the same trust assumptions, which means that they can all actually talk to each other, because they don't, if the P chain wants to talk to the X chain or the X chain to the C chain, etc., they are talking to validators that are validating the same things as them. So even though these are independent state machines and independent instances of consensus, they are operating in the exact same trust context in terms of who has a say over that network, which allows you to do some interesting things, and is actually how we handle atomic transactions to send value natively between these 3 chains without any form of external bridging. Could you ask your question again? I went on a bit of a tangent.
No, not at all. We love tangents here, and it's a great way to describe it and break it down from a nuts and bolts perspective. But bringing it back, was just curious to know how many validators are currently securing the 3 blockchains, and then what the requirements are to run a validator.
Right. I believe that there are about 1,400 validators on the Avalanche primary network today. You can look this up more easily than you can ask me. The interesting thing about this is that these are all validators that are actively participating in consensus. There is no committee election whereby some smaller group of them are participating in individual consensus decisions. There are larger validators and smaller validators, and one validator may not be queried by another node. That's actually kind of the beauty of the protocol. But every validator is involved in the consensus protocol the whole time, which is interesting, and a discrepancy between that and some of the other protocols that exist, which is quite nice. As for the software requirements, you can run this on Linux, Mac. Most people are running this on Linux, I believe. It just, if you're running on a server, it's that one of the most popular things. If you're running on Mac, Windows, all are pretty supported. We have builds for Mac, Windows, and Linux at the moment, so that people can just download those binaries and run them out of the box. Very straightforward. It's implemented in Golang, so you can compile and build from source. Let me know if this is kind of the direction you're talking about in terms of what software is required, but yeah, it's just one repo that you have to build out, to build or download the binary for. A lot of people run this on AWS, Google Cloud, Microsoft Azure, their own servers, their own home boxes. I think there are a couple of hardware solutions where people have built their own hardware that's specially sold just to run specific nodes. And then as for their hardware requirements, this is in the README of Avalanche Go. If anybody's curious to take a look at that, I don't know the details off the top of my head. Personally, I think I run my validator with about 500 gigabytes of storage, which is a bit it's a bit on the conservative side to make sure I have enough room and am able to have some archival support at times for the certain areas where I want to. And I don't know exactly what the bandwidth requirements are. It's nice to actually use a faster disk sometimes. That's for me as a developer. If I want to do something at turbo speed, disk is one of the most important things to optimize to improve performance. Yeah, I'd have to look at the Avalanche Go README to see what the current recommended specs are.
No, that was perfect. And if people want to know more information about how to run a validator, the minimum requirements, you can go check it out on their site. Rewards APY, off the top of your head, Aaron, do you know what that is?
Yeah, I missed that part before. Yeah, so the current minimum requirements in order to stake as your own validator on Avalanche is 2,000 Vox. I believe in order to delegate to another node, it is currently 25 Vox. As far as the reward curve goes, I believe that for both, it is roughly around 8.5 to 9% on an annualized basis. And if you are delegating, then you are delegating to some validator, and the validators currently are required to specify a delegation fee between 2% and 20%. And so that means that if you're delegating, you are losing some piece of your reward to a validator, but it ends up being pretty small. And depending on the amount of a Vox that you are actually trying to stake, it can be more profitable to delegate as opposed to running your own hardware. Really just kind of depends on how much you're trying to stake. If you don't have enough to stake your own node, if you don't have quite the 2,000, then obviously delegation is the main option. And there are also liquid staking options available on Avalanche. Shout out to Banky is a great one of those products. Yeah, does that answer your question, Noah?
Yeah, it definitely does. And final question, well, actually second to last question about validators. Do you guys have plans on lowering the minimum token requirement per validator to allow more people to participate?
So this is a really interesting question. This is actually something that we've discussed for a very long time. And originally, when we were discussing this, we wanted this to be one of the first decisions that would be made in a decentralized way by the community. And since then, it's been 2 years since mainnet, and we haven't gotten to that point yet. We're very interested in lowering that. I think that one of the interesting things is because you are required to be a validator on the primary network in order to validate a subnet. That means that the barrier to launch your own subnet can also be based off of that validator requirement too, and especially if you're trying to launch a subnet with a reasonable level of decentralization. Now, instead of needing to launch one node, you might need to launch 5 or even 10, depending on how decentralized you want it to be. So yeah, we're definitely looking into lowering that requirement. I'm not sure exactly where that process is now. We might implement some sort of on-chain governance in order to do that. We've been discussing this for a while, and unfortunately haven't gotten around to it yet. But definitely, there's an interest in doing that.
And do validators need to KYC?
Validators do not need to KYC now. It's an open and permissionless protocol.
I read that stake tokens on Avalanche are never at a risk of slashing. Could this, and this is from someone that's not technical at all, but can this cause issues since slashing typically is a deterrent for bad actors?
Yeah, so that's 100% right. There's no slashing mechanism on Avalanche. The reason for this is the sort of idea that, so yeah, to go into this a bit more, yeah, there's no slashing on Avalanche. So if you're putting up a stake, you're not going to lose that initial stake. You can be punished in terms of not receiving a reward. So if you are staking 2,000 Vox, you will not receive your 9% reward if there's some sort of Byzantine behavior, or if it's not behaving virtuously, you might not get your reward. Slashing's been a huge topic for a number of years, and I think around the time that Avalanche launched, we had the strong opinion that The whole purpose of slashing is to say if we are able to provably recognize that somebody has committed some bad behavior, we want to punish them, remove their stake, remove them from the network. And sort of one of the problems with this is the idea is that you should be able to, one, provably notice this, but if somebody is able to do something that is actually able to hurt the protocol, then they are conceivably also able to censor out any transactions that would um, they are conceivably able to censor out any transactions that would perform that slashing action. So the idea of this is that a consensus protocol would ideally make it so that nobody would be able to succeed anyway. So anybody that is performing some Byzantine action, ideally they won't succeed. If you take over 60% of the stake of the network, that is, Avalanche does rely on a majority assumption for a consensus, so that does obviously cause problems. Not really a huge concern. But yeah, so slashing is sort of this mechanism that handles the case where a very relatively small case where somebody has provably committed something bad that you want to punish, but then you actually have to perform that action on chain as well. So there's some concerns that I think slashing can have some value, but as of right now, I don't think that it's something that we absolutely need. I think we probably will want to consider some more strict requirements in the future in order for people to receive their reward. But the core idea of this is really just that the missing out on the economic reward of staking and running reliably should be enough to disincentivize people from running a Byzantine node, as well as the fact that ideally a well-formed consensus protocol will not actually allow somebody to do a Byzantine behavior and have any success.
And time to get to the bread and butter, and correct me if I'm wrong, but subnets are really how you guys made your name, and they're focal point of the ecosystem. But let's take a step back. What is a subnet, and how does it work, and how do they work in unison?
Yeah, so a subnet, at the simplest, the most computer science way of saying it is the way that I like to call it, is just a conjunction of a validator set and a set of blockchains. So what that means is that there is some validator set, just a collection of validators with some stake weight or portion stake weight allotted to each one of them, and then some set of blockchains that validator set has decided to validate together. The way that this boils down is that every subnet, the whole validator set, is some subset of the validators on the primary network. And this means that it allows it to have horizontal scaling, where you can have 5 validators of the primary network that opt in and decide we are additionally going to opt into validating this subnet because it has some form of economic rewards, or they can just decide to do it. And this means that people that want to validate that subnet can opt in to take on those higher validator requirements. So the nice thing about this is that a subnet adds no further requirements on the primary network itself. So you can launch a new subnet or a new Krobata, DFK, any other subnet. Dexalot is launching very soon as well. All of these subnets, they don't add any burden onto the validators of the primary network unless they choose to opt in, which allows people to have very nice properties for horizontal scaling, where those validators can actually beef up their hardware in order to support that subnet. However high performance they need, they can beef up that hardware in order to support it. Another cool thing about subnets is that validators can actually opt in to validate multiple different subnets if they would like to. So that means that if the economic rewards of validating a specific subnet A and subnet B, or let's call it Dexalot and DFK, if the rewards of validating both of those can actually compensate you for the additional hardware required, it could make sense to actually validate all of those subnets. But it doesn't impose any cost on the validators of the primary network that don't want anything to do with that or want to run a minimal node. So this is a really nice property. And the other interesting thing about subnets that I find to be the most interesting is the fact that since the validators of a subnet are all a subset of the validators on the primary network, this means that every validator of subnet A and subnet B knows exactly what the validator set of every other subnet on the network is. And this is super nice. If you're familiar with multi-chain and all the bridging solutions that exist, this is one of the biggest attack vectors that has existed in crypto for the past few years. I believe in 2022 there was over $1 billion, maybe 10 billion, or probably at least $3 to $5 billion of hacks that were just targeting bridges, which is absolutely huge. A ton of this was North Korea. It's not only bad for the space, it's legitimately bad for the whole world. Like literally, if North Korea is making very large amounts of money, it's sort of terrifying how bad this is. And there was a paper, a systemization of knowledge paper, that broke down what is required to implement a bridge really, really well. And one of the core ideas is that in order to form a bridge between blockchain A and blockchain B, it does actually specifically require some third party to authenticate trust between these 2 points. So if blockchain A has some validator set of 5 people that's completely disjoint from the validator set of blockchain B has no way to know what happened on blockchain A, and it shouldn't have to know what happened on blockchain A. That's sort of the whole point. And so what you actually have to have is some trusted third party, or not necessarily trusted, but some third party that attests to what happened on blockchain A and blockchain B in order to communicate between the two. So this is how most bridges work today. And it essentially, in most cases, boils down to you have some light client that serves as a point-to-point communication between two blockchains, which is a nice way of doing it. The great thing about subnets is because if you have access to the complete validator set from subnet A and subnet B, just by being a validator on the primary network as well, it almost lets you have that light client out of the box, is the way that I typically like to explain it. And this is really cool because now that you're subnet B and let's say subnet A is sending you some message, you know the complete validator set of subnet A. And so those validators can actually all work together to sign a message to subnet B, specifically naming subnet B. And subnet B can actually look up the validator set on the primary network on the platform chain and see exactly who the validator set is there, as well as what their registered BLS public key is in order to validate that signature. So now we went from needing to create this point-to-point communication between two different blockchains, to, which in many cases requires many different light clients, to actually just using the P chain essentially as that light client, as that trusted third party. And since this is already in the requirements of running a node, it really puts a minimal burden on the network. Another really nice part of this is subnet A and subnet B can actually communicate without putting any additional burden on the primary network. Another method that some people are kind of playing around with is having some larger chain or larger blockchain such as Ethereum, where messages are potentially passing through that network, and that way, instead of creating all these different point-to-point communication protocols, you can send a message to Ethereum and you only run the light client there, or something along those lines. The nice thing about inter-subnet communication is that, and this is called Avalanche warp messaging, actually, there's going to be lots more documentation, lots more to hear about this in the coming weeks and months. The really great thing about this is that those messages are just a signature created on subnet A, which only involves those validators and can be validated on subnet B receiving it and verify that signature without doing any work whatsoever on the primary network. So in the exact same way that moving some computation off of the primary network towards a subnet only imposes additional cost on the validators that opt into it, Avalanche warp messaging works in the exact same way, in that there's no additional cost whatsoever to the primary network, that is.
So to sum it up, quite the intricate and robust system. I want to take a few steps back and ask, what's the cost, first of all, for setting up a subnet? And what are the minimum number of validators required to participate in supporting that subnet? I know that seems to be like an infinite number can come in and based on an economic incentive be a part of validating or supporting that subnet, but what's the minimum?
So there's technically literally no minimum. You can actually have a subnet with 0 validators, and actually because lots of people have been playing around with this and didn't quite get the full way, there are plenty of subnets with literally 0 validators. Now, of course, that's not particularly useful, so I don't recommend that. You can run a subnet with a single validator, and this could actually be useful with Avalanche warp messaging. One of the ideas that I find incredibly fascinating is the potential to use a subnet as, and this would probably not be the most scalable right now with the cost of setting this up, but if you just run a subnet, all of a sudden you can use Avalanche warp messaging to potentially communicate with any other subnet that's out there, which could potentially be really, really interesting, even without high level of decentralization on that subnet. Just with the ability to use that subnet to communicate to all of these other blockchains that are out there, I think could be extremely interesting. I'm really excited to see people play around with it. I have some of my own ideas on what some interesting things you could do there are. Based on this is actually the number of validators that you should have on a subnet is really based on the consensus protocol itself, as well as what are your decentralization requirements and what are the trust assumptions of your subnet. So for example, if you're running a permission network, you might be completely okay with saying there's going to be one server, one node. We're actually even okay with downtime because, obviously you will at some points in time have to turn off a machine, update the software, etc. If for your subnet, for your use case, you're actually 100% okay with a couple minutes of downtime in order to perform a software update, you're okay with a high level of centralization, you can absolutely run a subnet with a single node. However, if you are trying to actually get the real benefits out of a lot of the principles of blockchain, decentralization, which I'm not, this is not to say that it's always required, but if you're trying to run a much more decentralized subnet with the goal of using this to avoid downtime as well as to avoid censorship resistance, as well as to involve many different parties, then I would say the minimum that I would recommend is closer to 10. So when we were actually running the test network on Avalanche, we were actually running 20 nodes, as we found that was a pretty good happy medium number. We're not burning through too much money to pay for AWS costs, but 20 was a pretty good number, where if we took 1 or 2 nodes down, or even 3 or 4, it was okay. It didn't cause the network to stop or anything, and we could just turn them back on, and it gave us a pretty reasonable level of fault tolerance. So I would say that 10 is a good starting point. And as you are considering building out a subnet, one of the really interesting things is a lot of the people building these are application builders that haven't necessarily had to think about things like proof of stake and all of the different trust assumptions that go on when you're building actually or considering and dealing with the consensus protocol itself. And so a lot of people, they're used to building a dApp, deploying it through Ethereum, and they're like, yes, it's decentralized now. When you're launching a subnet, you're essentially launching your own L1. You actually have to worry about promoting the decentralization of that subnet, incentivizing it the right way so that it does get to the right place. You're not allowing, some North Korea to take over 40% of the stake of your network or anything like that. So this is pretty interesting, and it's something that's can be a little bit foreign to developers that are new to that world. Yeah, it's a very, very interesting thing to get right. Yeah, I lost my train of thought there a bit. Could you bring me back to the question, Noah?
No, it's spot on. You answered the question, and the follow-up question I had, because you just said that you have some ideas for awesome future use cases. So tell us a bit about that, if you don't mind sharing.
These are early stage ideas of things that I haven't really thought all the way out yet, but yeah. Sorry.
Yeah, no worries at all, man. We can skip to. So you guys recently had a massive partnership with AWS, and so I would love to know a bit more about AWS's one node or one-click node deployment and how that's going to work, or when we're going to see those at all.
Yeah, I can jump in here. My name is Justin. I do BD on the enterprise side here at Avalabs. So yeah, the AWS deployment, I mean, you can actually go to AWS Marketplace today and spin up an Avalanche validator in one click via the marketplace. So that's live today. There are other features that we're looking to add with AWS in the near future. I think you've kind of alluded to it this entire time, but a one-click subnet deployment on AWS is on our roadmap, as well as a more managed service for AWS validators. Or Avalanche validators running on AWS, meaning that any patching, any upgrading, anything like that is actually managed by AWS, and the end user doesn't actually have to go through the scripting and updating that way manually.
And I'm assuming that AWS, them offering subnets as a service, and also you guys looking to bridge the gap between Web 2 and Web 3, that's critical, but would love to know what other partnerships will be needed to make this dream a reality.
Yeah, so there's a lot going on in the background, as you can imagine, with AWS. They actually have some very crypto native folks who are working there and have some pretty lofty aspirations for what they want to accomplish. So without going into specifics, as I'm not at liberty to discuss specifics, we are working on a number of other projects with AWS. There was something that was leaked pretty recently, which is very cool, surrounding AWS, something that we're looking to be a part of. And then obviously just honing back into what we're trying to do. I think back to what you were saying is, we're giving enterprises, institutions, governments the ability to create subnets, run subnets, and interact with blockchains in environments that they already know. That's the beauty of the partnership with AWS is, these enterprises, they're not going to jump out on a limb and start building in a unique environment. They want to build in
someplace that they're comfortable with, somewhere where they already have their tools, where they already have their operational security set, their IAM and whatnot. So that's why this AWS deal is so important to us and so important to the enterprises that we're speaking to, is because we give anybody the tools that they need to operate and build in an environment that they already know.
We talked earlier about the importance of folks being able to interface with this stuff where they're not seeing what happens in the background. It's very much like interfacing with Web 2. So with that said, are there plans, if not already, to make one-click node deployment something where anyone can just fill out basic parameters, relatively basic parameters, without having too much technical background, such as, for example, Aaron's breaking things down, and like a lot of this stuff goes over my head because I'm not a tech guy. Is there a way to condense that into something that the average person can use and set up a subnet?
Absolutely, yeah. That's kind of the end goal with AWS and some of the other hyperscale clouds, is to basically abstract away a lot of the complexity of running and managing nodes. A lot of enterprises that we speak to are pretty hesitant to change, and they don't have entire Solidity developer teams ready today. So they do rely on third parties to help implement these validator nodes or subnets or NFTs, whatever it may be. And the goal there is to help upskill those enterprises, institutions, systems integrators, and also give them the tools to make it as simple and intuitive as possible. So I would say in the near future, it's something that's on our roadmap to make launching an Avalanche validator very, very easy to do and not really need any, too much, I would say. You still need a little bit of technical experience, but you're not going to need a full amount of technical expertise, I would say.
Mm-hmm. And guys, what is the plan for interoperability with other chains? Are subnets the end game, or do you guys have more in store?
When you say interoperability with other chains, are you talking about interoperability with like completely different ecosystems or interoperability within the Avalanche ecosystem?
Other ecosystems.
Yeah, I think that's sort of very separate from the way that Avalanche Ware messaging and our inter-subnet communication works. So I think this is going to be a bigger story that largely happens externally to Ava Labs. There's maybe some possibility. Actually, there's an interesting possibility that other people could use a light client of the P chain, which currently doesn't exist yet, but is pretty doable, to actually interact with any subnet on Avalanche. If they integrated with the way that Avalanche Ware messaging works, all that they would really need to know is to have that light client that's able to give you access to the current PChain space or the current validator set of all of the different subnets that are out there. So there's probably something interesting that could be done there in order to give developers in other ecosystems, other completely different multi-chain ecosystems, direct access not only to the Avalanche primary network and not necessarily requiring people to build point-to-point communication directly to every subnet, but actually integrating once and then suddenly having access to all of the Avalanche Ware messaging that's going to exist within that ecosystem. But it would still require that bridge between the Avalanche ecosystem and whatever that other multi-chain ecosystem or just single chain ecosystem would be. So I think that's largely going to be dominated by a decent number of other players that are happening in this space. There's a lot of great people, a lot of great builders that are doing a lot of work here. I could name a couple. There's some interesting stuff in the security community happening today with them, so won't go into any names of places I like or anything like that. But yeah, it was a very competitive space there, for sure.
And I guess one more question for you, Aaron, or this next one's going to be for you. From a high level, what would you say Avalanche's subnet model has as far as advantages over Polkadot's parachain model or a future Ethereum with sharding and dozens of highly scalable layer 2s?
I think there's two things that I like about it. One is I think that the Avalanche consensus protocol can potentially very desirable properties and a very, very nice separation between consensus and the state machine. Those I think are really nice and gives people a lot of flexibility in terms of what they are going to build on top of. And the other, I would say, is just the subnet model and what that allows you to do in terms of horizontal scalability, where you can actually opt in to validate these additional networks and increase the hardware requirements in order to beef up what throughput you can get on those subnets. And then lastly is just, yes, I think Avalanche Ware messaging is actually a really good solution. I'm not that much of a shell, I'm more of an engineer, but I would potentially say the best one on the market for actually being able to interact extremely easily with minimal overhead. And this is something, we're continuing to develop. So props to all the other protocols that have already launched this and are already using this in production. Avalanche Port Messaging, we've used it on one VM, but we're still working on integrating into the EVM. So props to all the other ones because they are further along in that journey than we are. But I think the core design is really, really interesting and hopefully is going to make it easier to build on Avalanche than it is to build any place else. And I think that's really the goal, is to compete at that sort of platform level where we are making Avalanche the most interesting place to build. And as soon as you launch some subnet on Avalanche, some VM on Avalanche, your blockchain on Avalanche, you are just immediately plugged into that ecosystem where you have a fast consensus protocol better than anything else that's out there, and you're immediately plugged into this interoperability framework where you can interact with anything else that's on the Avalanche ecosystem, making it really that best place to build a whole large number of different applications. That's kind of the takeaway for me.
I was reading about Boba Network and how they're deployed on ETH, AVAX, Moonbeam, and BNB. Curious to know, in what ways can Avalanche benefit from layer twos?
I'm actually a huge fan of layer twos, which has been an unpopular opinion from some folks at Avalanche, but I think they actually bring a huge amount to the ecosystem, and I think we're shifting to embrace them a ton more. They're getting a ton of mind share in the Web3 community today, and I think they're a really, really great invention, and I think they can actually fit extremely well into the subnet narrative. The reason for this is that the core primitive that I think layer twos provide is this idea of trust minimization, where any type of consensus protocol that you have that's out there, it's going to rely on the majority of validators behaving honestly. So actually more than a majority, but if you have 70% of validators are behaving dishonestly, they're trying to cause other people to have problems, then that network is not going to work. And the reason for that is, 70% of people are saying A happened and then B happened. You're going to lose liveness, you're going to lose safety properties, and consensus protocols just sort of fall apart if you don't have that majority assumption. The whole point of layer twos is that they assume that there is some L1 that they can roll back up to, where they just assume, okay, that is the place where you take care of the majority assumption. And then you can have some smaller network where you can actually have a 1 out of N instead of a majority of those validators that you trust. And the cool thing about this is once you do that, you can have much, much smaller networks without giving up nearly as much in terms of trust or security. And I think that subnets provide a really, really interesting place to build L2s because you can get decentralization and consensus out of the box, and you can use Avalanche Port Messaging to potentially post data back to the primary network in the future, of course, very, very easily and interoperably. And I think that's a really, really powerful narrative that a number of L2 builders are potentially very excited about using and leveraging. And I think that's definitely something that you're going to see a lot more from the Avalanche ecosystem. And so I'm really, really excited for L2s. I think they add a ton, and I think they're going to be very likely a big part of how Web3 gets adoption, if it does, is using L2s to unlock a large number more applications and decreasing the barrier to entry to building really, really scalable application-specific chains while maintaining a high level of, or a low level of trust, or sorry, a high level of trust in the application, a low requirement for trust, and a very high level of security. I think it has some really cool potential.
I think if folks were listening to the broadcast earlier, they might be able to piece together the different ways that Avalanche is working through the blockchain trilemma. But if there's anything with regard to that, Aaron, that you think is important to share, go ahead and do so now before we move on to tokenomics.
Yeah, I mean, I think that the blockchain trilemma is really just this. It's a sort of a thing saying doing these three things at once is hard. It's not that saying that doing these three things is impossible. And I think we're actually getting to a point where it's like, okay, you can actually do all of these things. There's definitely trade-offs between them, but it's not impossible to hit all of these core tenets or goals. So I think Avalanche has done a really great job of achieving decentralization, scalability, speed, throughput. I don't actually remember exactly what the three tenets are. I don't think this is as relevant today as it once was. I think it's at least three of the things that I just said. Daniel,
Yeah, you got it. Yeah, decentralization, speed, security. You got it.
Speed, security, yeah. And so Avalanche does a really good job of this, and I think I think this is probably not going to be as important as it was a few years ago, as consensus protocols have continued to develop. And what was once doing these three things is either impossible or hard is now, okay, we can do all three of these things at once in a really nice way. And the L2s actually are a huge benefit to this as well because of the ability to say, okay, sure, you require a consensus protocol to provide all three of these, or you can have a layer one that provides very high level security, but then you can have speed through an L2. And I think that's actually very, very compelling to say, all right, the blockchain trilemma, maybe not within one blockchain, but the goal of this is not to build a single blockchain that has all three of these. The goal of this is to build secure and reliable distributed systems that people can use. And I think that for that, integrating all these different pieces allows us to build interesting applications with all three of those in a really nice way.
I've heard very positive feedback in regard to Avalanche's tokenomics. So just from a high level, do you guys mind giving us a quick breakdown of the tokenomics, token utilities, and anything else that we might need to know? I'm not sure who's, I guess, I wasn't sure who to direct that question to, but go ahead, Nikhil.
Yeah, happy to take that on, and then I'll pass it over to Matt, who might be able to add some more context. But the general idea for the Avox token utility is pretty interesting, and I think that's what sets it apart in many ways to a lot of other sort of modular, horizontally scaling blockchains that are there. As Aaron had mentioned, there is the primary network. So if you want to spin up a subnet, whether it's an enterprise subnet, a gaming specific subnet, what have you, then you do have to go through the primary network essentially and run a validator there, take a slice of those validators, and then you can run your own subnet. So this adds an extra utility for Avox long term, where basically you're able to, if you want to be able to create your own blockchain, you have to stake Avox in that sort of manner. This is different than a lot of other horizontally scaling blockchains where things are entirely separate, and essentially it's more of like a sidechain as a service where everything is entirely separate and you don't need to utilize the token at all in that sort of manner. So that's definitely something that's interesting on that front. The other thing is also that there are services that for example require a Vox to be used. So on the C chain, for instance, which is sort of used as the general hub of liquidity. So once more and more subnets go live, which they are now, and as Aaron had mentioned with Avalanche warp messaging as well, what a lot of projects are looking to use is use the C chain as a liquidity hub, has the highest amount of security, so it makes sense to kind of draw liquidity from there. But of course, on the C chain, you basically need to utilize a Vox as the gas fee. So there are two main sort of long-term utility factors for a Vox there. As more subnets sort of are spun up, there is more Vox that needs to be locked away. This includes not only for enterprise use cases, but even permissionless ones. If somebody wants to spin up their own permissionless L1, as for tokenomics, of course, there's a finite amount of a Vox, and that's mainly because the primary utility for a Vox is to basically spin up subnets and utilize it for applications. I'll pause there for any questions, and also if Matt wants to fill in any gaps I may have left out there.
Yeah, I guess two things I'd like to add as well is I think some subnets will actually utilize Avox as the gas token, so that'll add sort of another deflationary mechanic depending on what they do with those fees. As well as, like Nikhil said, there's a finite amount of Avox in which the percentage breakdown is released publicly, but right now most of the inflation is directly from staking.
So I guess I'm pretty clear on all that. Is there max supply? You guys might have said it and I might have missed it.
Yeah, I believe it's 720 million, but correct me if I'm wrong, members of my team.
Yeah, that's right.
This is a question from a community member, and I have it on the sheet, but I don't have as much context to elaborate on it. The question was, is the Avalanche network quantum secured, and are you building quantum resistant solutions?
Aaron, you want to take that or have any context on that front?
Sure, yeah. No, it's not currently quantum secure. It's definitely something that we have on our radar. A long time ago, actually, prior to public mainnet launch, we were working on a quantum safe cryptography scheme for transaction signing, which was an interesting project. We didn't fully finish it, or at least not merge it. I think the PR is actually still up on the public repo, but we were actually kind of waiting for NIST to finalize a sort of a standard in what quantum safe cryptography would be, sort of a recommended library. And I think we had somebody take a look at 3 or 4 different options that were out there and decide on one to go ahead and implement. The quantum safe cryptography is something that's still very much a work in progress, and it's hard to say exactly how far away it is that we're actually going to need it. I would say this is an interesting question. But I don't think this is something that's going to be a huge concern in the next 2 to probably 5 years. in my estimate, and we'll probably see much more progress, much more clearly, well before it becomes a concern. Could be definitely wrong about that. We'll see. If so, the whole world is not quantum safe. So there are much bigger concerns than, to be honest, all blockchains, but also Avalanche specifically. Yeah, this is something that's going to be a global movement to switch to quantum safe cryptography when it becomes necessary. And I think that's probably a little while away. If you disagree with that, you should be very scared because a lot of stuff is not quantum safe.
Yeah, it's kind of, I'll draw an analogy. It's kind of the same thing that I tell people when they say, well, what if the internet goes down? What am I going to do with my crypto or my Bitcoin? I'm not going to be able to access it. I said, if the global internet goes down, then you have bigger problems. Something cataclysmic is probably happening to cause that.
Aaron
likes to use something cataclysmic
solar
hasn't
flare
happened.
analogy too.
Oh yeah, I'm a big fan of solar flares. They're terrifying. Yeah.
Guys,
is not quantum
go ahead,
safe
Aaron.
nor
Sorry.
solar flare safe if the entire power grid is wiped out. So solar flares and quantum cryptography, big worries, not just for Avalanche, not just for crypto, but the whole world really. This is my conspiracy theory / into the world side. But yeah, very interesting potential concerns for the world.
Well played. Guys, I used the Avalanche bridge quite a bit during the bull run. I mentioned earlier that a lot of my friends who were native to crypto got into the ecosystem, or rather got into the space, were very interested in participating. And everyone collectively told me the Avalanche experience, and this is my anecdotal experience, the Avalanche, my anecdotal feedback, the Avalanche experience is the best one. So I used probably a dozen bridges in my time participating in different liquidity incentive programs and DeFi. And for whatever reason, as far as just how fast it worked, the relatively low gas fees, because a lot of other bridges I ended up paying like hundreds of dollars in like Ethereum gas fees. I'm not sure why they were all so high, but also just something as simple as an airdrop once you arrive to the ecosystem, which, believe it or not, bridges like Polygon did not have. I had friends that bridged over to Polygon and they were like, hey, I don't have anything for gas. Can you send me some Matic? So let's talk a bit about the Avalanche bridge and why it's so awesome. I mean, I'm just going to say it outright. What did you guys do differently?
Aaron, you want to take that? Or, Matt and I can also talk about the bridge too.
Sure, I can talk about it a little bit. I think actually, so there's two things, I guess. The first one is, when you have a network that's actually faster, that's where a lot of the latency comes from in all of these bridges, is you have to have a transaction that happens on both chain A, the sender, and then also chain B, the receiver. So if you have interacted with that Avalanche bridge both ways, I forget which, but it's actually slower in one direction than the other because of, or at least the transaction will show up. Yeah, so if you send Avalanche or a Vox from Avalanche to Ethereum, as soon as that transaction is finalized on the Avalanche network, you can send the withdrawal on the Ethereum network. If you're sending something from Ethereum to Avalanche, you have to get some number of confirmations first on that network before it's safe to actually mint the corresponding funds on the Avalanche network, the corresponding kind of wrapped funds. So the reality is that because one of those sides is so fast, you can actually reduce the latency in a really, really large way, which is a really, really nice property. And I think that's one of the big reasons, like we talked about before at the very beginning, with how Avalanche improves that user experience. It comes down to that. That's the lower transaction latency in action, giving people a better experience when using products like bridges. The other thing is, I think we had the opportunity to learn from a lot of the different user problems that had existed in different bridges, and saw, okay, having an airdrop is actually incredibly useful, because if you bridge your tokens and don't have any Vox to pay the gas token fees, then all of a sudden you can't do anything with it, and it's not very useful. So I think we had the benefit of a number of great innovators that come before us in terms of building bridges, and we were able to learn from some of the things that led to user problems on those bridges and make that experience a little bit better and a little bit more seamless. And also there's a fantastic engineering team that worked on that bridge and is now working on Avalanche port messaging and some applications built on top of it as well. So going to see a lot more great things coming out of that team too. I do actually have to drop off for an interview really quickly. So thank you guys so much for having me on. It was fantastic to be here and great to meet everybody.
Yeah, thanks for coming on, Aaron. Good luck on your interview. Really appreciate all the breakdowns.
Stay good,
Yes,
sir.
Have a good one, guys.
All right, so let's see. I want to, guys, the assets ending in .e, that just means that they came in through the AVAX bridge. How are wrapped AVAX assets different from, let's say, wrapped assets on other chains, or is it pretty much the same mechanism on the back end?
So the way that wrapped assets work on Avalanche so if you see the sort of suffix .e, that means that basically it's an asset that came over from Ethereum. So there's like BTC-B.E that was initially basically wrapped BTC that came from Ethereum. There was also other assets as well that came that way too. So the way that it basically works is that when it comes to the bridge, unlike other bridge networks, it leverages the security of the Avalanche Ethereum bridge, the SGX bridge, which has several wardens. Whereas in the case of other wrapped assets, they may use a centralized custodian provider like BitGo, for example, where they will basically they'll use like a single person that is basically managing all of those assets. So that's essentially the way that it works there, and yeah, it's the main differentiator.
Oh, sorry. I think I might have been talking there with my mic muted. So BTC.B, what are some of the reasons people might use it over WBTC? I know that it just means that the asset was bridged directly from Bitcoin rather than from Bitcoin to Ethereum, then Ethereum to AVAX.
Yeah, exactly. So basically, the native Bitcoin is obviously preferable than bridged Bitcoin from Ethereum, and is even more preferable than utilizing a centralized service like WBTC or something like that. This is obviously because it comes directly from the Bitcoin blockchain. It leverages a decentralized network of folks that are basically managing the bridge also, which is definitely far better than a single custodian. And so our whole philosophy around that was that how can we create a better form of wrapped BTC that is more decentralized, and how can we also allow for the large community of Bitcoin holders and Bitcoin fans to utilize their Bitcoin in DeFi, instead of using a more centralized service. So yeah, that's sort of the high overview there.
I'm going to skip a few questions because I know you guys have to wrap up here in a bit, but I did want to focus on some important things. A lot of L1s currently general purpose, but as more come in, you need to start differentiating yourselves. So I would love to talk about some of the sectors where AVAX is really starting to stand out: DeFi, NFTs, and gaming. Guys, if you wouldn't mind just kind of going into each one of those and tell me about the different ways you guys are setting yourselves apart, that'd be amazing.
Yeah, of course. I can briefly cover DeFi and gaming, and I can pass it over to Dan, who will be able to cover NFTs. But on the DeFi side, as mentioned before, Avalanche basically is able to leverage its consensus and its extremely optimized latency for financial products. So you'll see a lot of top institutional platforms building on Avalanche. For example, working closely with Golden Tree Asset Management, Aave, and Securitize to build a institutional DeFi subnet. Now, this is great for them because they're able to configure their own network in a way that they're actually able to interact with DeFi in a safe manner that is compliant, but while also being, quick and fast. So that way they don't have to basically wait for seconds, minutes, or even, hours for confirmation. So that's definitely really useful there. And with Avalanche Consensus, you're able to get things like, for example, Dexalot, which is a really interesting central limit order book subnet that's launching on Avalanche, and products like that. So that's a really cool thing about Avalanche. And I think because of its really robust DeFi ecosystem, you see a lot of innovation on, like, for example, the options side, and there's also fixed yield protocols. So there's a lot of innovation that's going on the DeFi side. It's not just a bunch of forks, but actually a lot of traditional financial researchers that are coming over to Avalanche, and they're using it because the tech is really promising for that. On the gaming side, a lot of traditional game studios are building on Avalanche. We just announced a partnership with Gree, the Japanese mobile gaming giant. They've partnered with folks like Square Enix, Bandai Namco, and like EA, Ubisoft, and a bunch of major names. And they're working with us primarily because they sort of described it that Avalanche subnets are the best poised for building games. This is because the configurability, it allows them to be compliant in their respective regions, and also subnets are the only way for them to scale to millions and millions of users while being able to have like sub-second finality and good UX. So Avalanche is becoming a hub for gaming on that side, not only on the traditional gaming side, where we are having many partnerships with game studios, but also brand new games that are being built from the ground up on Avalanche as well. So that's definitely quite exciting. So I'd say stay tuned also. This quarter we'll be announcing one or two massive partnerships on the gaming side with some names that you guys might be familiar with. I'll pass it over to Dan, who can close things out on some of the great things happening on NFTs. And it was great chatting with you all. Thanks for having us here.
Nikhil, thank you so much for coming on, man. It's been a pleasure.
I'll give the quick rundown as well here. Avalanche wants to be seen as the tagline shows, create without limits platform. So we want to onboard, several hundred creatives this year, from traditional Web3 audiences and also non-Web3 audiences in different parts of the world that might not be seen as popularized for Web3 at this time. I also want to highlight, and we have been doing a good job of highlighting native ecosystem artists. So want to keep on growing their platforms and getting them the promotional spaces to get involved and actually build their brands and their identities in this space. Taking on some non-traditional approaches. In short summary, we just announced a project with Ed Balloon, a well-known artist in the space, to do a concert series with himself, JPEG Mafia, who's a awesome artist as well, and Clipping, another great artist, to do a live concert NFT with NFT focus in LA, where everybody just needs to basically have an NFT to get in. It's a free ticket. And from there, the NFT will give you a lot more access to other things inside the concert experience as a whole, kind of showcasing a whole ecosystem of different partners in the Avalanche ecosystem with some really cool visuals and live music. We're looking at push a lot of these kinds of things forward that aren't really being tackled or approached yet in other chains or other even marketplaces, to just have experiences that make you say whoa or wow, and showcase what Avalanche's technology did for many and still does for many to this date, but in a more intimate, tied experience. And then, just proper representation of all types of artists and creatives long term. There are plans, obviously, for enterprise and supply chain side of things, but those are more longer term plans. And in term, I think the best way to onboard is with a lot of the creative mind share being experimental and open to create their next big piece here. In the interest of time, I'm gonna cut off there as well.
Yeah, of course. I'm sure we can go all day, guys. Listen, Daniel, I really appreciate you putting this together and bringing on other members of your team. This is incredibly educational and informative. We learned a lot as far as the tech is concerned, the different plans you guys have to innovate with subnets, the different ecosystems you're building out with respect to NFTs, DeFi, and gaming. One last question from both of you, since I still have you on here. What excites you, and there's a lot that's coming up, but what excites you most? If there's one thing that really gets you your blood boiling about 2023, share that with us and we can wrap things up.
Sure. Yeah. Happy to do that there. So for me, what I'm really excited about is that a lot of the great things on the Avalanche roadmap are coming together, this year. So, subnets have been live for a bit. We've talked about, a interoperability protocol, but, for the first time this year, we're going to have the ability for anybody to spin up their own permissionless subnets this year for their own enterprise applications or general purpose applications. And there's going to be a protocol to allow them to all communicate all in one together. So that's the first thing that gets me really excited this year. That I think the roadmap is really coming together, and it's finally in a place where everybody can start testing things out. And we're going to get a Cambrian explosion of subnets this year. The second thing I would say is that is basically from my side, I'm biased towards gaming. There's a lot of really large gaming partnerships that we're going to secure this year. So I'd say stay tuned. That's what gets me excited. I'll pass it over to Dan, and then again, thanks everyone for having us on. And again, thanks for organizing this, Dan, and the rest of the team, such as Noah and Will Coin Talk.
Yep. And on my side, infra, from AWM, our messaging protocol, to the ability to deploy subnets with more customization, to even at the creator contract side. A lot of what is being done out there hasn't been done yet. When I say out there, it's behind closed doors. So we're really excited to kind of showcase these things at large scale to our audiences. Can only tease, can never please. But yeah, that's kind of where we're at right now.
Daniel, Nikhil, it's been a pleasure. Audience members, if you enjoyed this, and I should have done this at the beginning when everyone else was in here, but throw Daniel, Nikhil, CK a follow. If you like what you're hearing, throw the Whale Coin Talk team a follow. And Whale Coin Talk community, remember that everything you hear on these broadcasts is meant for educational purposes only. Nothing is financial advice. So be safe out there. That was the team at Ava Labs. My name is Noah, signing out. Take care.
Thanks for your time, y'all. Appreciate it.
Thanks, everyone. Cheers.